Okay, welcome back, grade 7. This is your nine fur coming back from your long eggnog and gingerbread induced comas. So welcome back to the real world. Here are 9 questions you can try to see how much you remember over the break. The first question says, what's the probability of spinning a 1 on that spinner and flipping a heads in the coin? So in order for us to do this question, we have to create a table of values. So we can do a tree diagram if you want. So the first event is a 1, a 2, or a 3. And the second event is the coin, which is heads or tails. So as we can see from our table, that inside here, our sample space gives us 6 possible outcomes. And the one we're looking for is a 1 heads, and of the 6, there's only one of them that is 1 head. So as a fraction, the probability of it happening is 1 chance out of 6. But as a decimal, if I change that fraction 1/6 with the calculator, if I change 1 divided by 6 to a decimal, I get 0.16666, which is approximately equal to 16.6 repeating percent, or approximately 16.7%, or approximately, if you want to round to the nearest percent, 17%. Our second question gives us this Cartesian plane and asks us to label all of the points. I'll do them in green here. The first one, A, is 2 on your x and 0 on your y. B is 1 on your x and negative 2 on your y. C is negative 3 on your x and negative 3 on your y. D is 0 on your x and 2 on your y. E is negative 3 on your x and 0 on your y. And finally, F is negative 2 on your x and 1 on your y. Okay? Next question is question 3. And I've given you 3 fractions and asked you to reduce them all to lowest terms. So what you should be able to acknowledge is that all of them are divisible by probably their numerator. So in the first one, we know that both are divisible by 2, giving us 1 over 22 as an answer. In the next one, because we know 111 is divisible by 3, because 1 plus 1 plus 1 is 3, and the sum of that is divisible by 3, so we'd have 1 over whatever 111 divided by 3 is. And most of us remember now it's 37, because we've used that quite a few times. The next one, I can divide both by 4. Give me 1 over 21. And the last one, I can divide both by 5. Give me 1 over 24 in lowest terms. Not 1 over 25, but 1 over 24. Question number 4 says, what is 20% of $82? So for 20% of $82, 20% of $82, I want to first find mentally 10%, and I move my decimal one place over to find 10%, which is $8.20. So if 10% is $8.20, if I doubled that, I'd have $16.40, which is what 20% of 82 is. If I look at the second question, it's 15% of 124. So 15% of 124. Now, obviously, if you have a calculator, you're probably going to use a calculator for this because you realize that 15% is 15 hundredths, and 15 hundredths as a decimal is this. The word of is usually implying multiplication, and you have 124. So if I used a calculator, I bring up my calculator and go 15% of 124 is, and the answer would be $18.60. The other way you could do it is find that 10% is $12.40. 5% is half of that, which is $6.20. The sum of those two is still going to be $18.60. And the third question says, what's 49% of $140? So 49% of 140, or sorry, of 140, how much? $140. We could find 50%, which is half of it, which is 70. We could find 1%, which we'd move the decimal 2 places over, which is $1.40. And to get 49%, I would subtract them. So $70 take away $1.40 is $68.60. 6860 is your third one. The next question is a chart. It says the decimal is 0.6. What's that as a fraction? Well, it's 6/10 as a fraction. That's not a wrong answer. But since we're always looking for lowest terms, what I would expect to see from you is reducing that to 3/5, because you can divide both 6 and 10 by a factor of 2. As a percent, 6/10 is equal to 60 hundredths, which is equal to 60%. 60% as a percent. So 2% as a fraction is simply 2 out of 100, which in lowest terms is 1 out of 50. And 2 hundredths as a decimal is still 2 hundredths as a decimal. 11 twentieths, if I treated 11 twentieths and made it into an equivalent fraction out of 100, it would be 55 out of 100, which means it's 55%. And 55 hundredths, written as a decimal, is 0.55. 55 hundredths. Your next question is a sum of two fractions. Since you're dealing with mixed fractions, you can either add the whole numbers first and then add the fractions together, which is usually the wisest thing to do. But I always use the same algorithm for any fractions that are mixed. I simply change them both to improper, find my common denominator, change them to equivalent fractions, add the numerators, and get your final answer of 1 and 17 twentieths. Same thing happens in the next one, especially with subtraction. It's easiest if you change them to improper. Find your common denominator. Change to equivalent fractions. 26 tenths take away 19 tenths is 7 tenths, which is lowest terms. Your second last question is adding three fractions. I can still find a common denominator for all of them, in this case 10. 3 tenths won't change, but this one will to 5 tenths, and this one will to 2 tenths. When I add my numerators, I get 10, so 10 tenths is really the answer, 1. Your final answer is 1. And your last question says true or false. 2/3 is equal to 0.66666. If I take my calculator and go 2 divided by 3 to change that fraction to a decimal, it tells me it's a lot longer than that. In fact, it's 0.6 to infinity, so the truth is the answer is false unless those 3 dots were there, or I wrote it using bar notation, 0.6 with a bar above it. That would mean it repeats. So the answer is false. It is not true. It is not equal to 0.66666. It is equal to 0.66666666666 to infinity. So it's false. And the last question, 7/11 is greater than 3/4. In order for me to compare them, I should have one of two things. I can either change them both to decimals. So 7 divided by 11 is 0.63 repeating. Is that greater than, well, we know that 3/4 is 0.75. Is that greater? No, so it's false. The other way we could compare them is change them to equivalent fractions that have denominators of 44. Since I multiply this by 4, multiply this by 4, I get 28 44ths is greater than 33 44ths. The answer is still false. It's not a greater fraction. So no matter which way you compared them, the answer is false.